Hi, thank you for joining me. I'm Tal from Meta, and in this short video I'll present the main idea of the paper Mind the Gap, delayed label bias-variance trade-offs in predicting the likelihood of non-payment. In this paper, we considered an online electronic payment risk detection system which approves or declines transactions. The purpose of the system is to prevent leakage by making sure only genuine transactions pass. Typically, for such a problem, a machine learning model is trained over past transactions and payment labels. However, this setting suffers from two main challenges. The first challenge is labels delay gap. It typically takes more than 45 days until we observe the true label of a payment, and therefore our labels for the models are delayed by at least 45 days. The second challenge is model drift. The distributions of the features and the labels are changing over time, and therefore a model that was trained using past data is no longer accurate. Combining these two challenges, we have a unique situation here, where on one hand, we want to use the most recent data in order to train our model, but on the other hand, we only have data that is at least 45 days old. In the paper, we suggest bridging this gap using pseudo-labels. In short, we train a model using post-transaction features and use its predictions to construct pseudo-labels. We leverage the pseudo-labels to update our model and that predicts the likelihood of payment. The pseudo-labels are noisier than the true labels, but using them, we can overcome the model's drift, so this can be viewed as a bias-variance trade-off problem. We support our methodology with a theoretical framework, and we will show that using this approach, we were able to improve the performance of existing models in Meta, in empirical offline evaluations, and online experiments. The key takeaway from this video is that by constructing pseudo-labels using post-transaction features, we were able to reduce the gap between the deployment time and training time of the model from 45 days to just 2 weeks. Our approach is generic and can be applied to similar domains and generalized to additional models. We are very excited to present our paper at the upcoming KDD and hope to see you there to continue the discussion.